Welcome back and welcome to section 3, an introduction to object-oriented programming. In this section, we're going to get an overview of what OOP is and how to design our applications for OOP, as well as some examples of how we can utilize some common OOP practices. So welcome to video 1, an introduction to object-oriented programming, objects and classes. So I'm assuming you pretty much have no knowledge of OOP, so I'm going to give you a sort of from the ground up description of what it is and why we use it, as well as some of the basic building blocks of OOP, which are objects and classes. So first of all, what is object-oriented programming? Well, in OOP, everything revolves around the concept of an object. And I want you to think of an object as something that is similar to a real-world object, such as a television or a car. So an object is a real-world concrete thing. So think of an object like an actual instance of a television. And this is a really, really key thing to keep in your mind. An object is your actual television, not television as a concept. That's something else called a class. But an object is the actual realization of a design of something. So software is divided into these objects around which the data and functions are also built. So an object is actually a concrete implementation of something which has been pre-designed. So this design is called a class, and I want you to think of a class like a blueprint for an object. So just for a moment, imagine you were a buildings architect. The architecture design, or your blueprint, would be a class, and the building itself, once you've constructed it, would be an object. So if you were an architect for a home building company, you might actually make many models of the same house. Now, you'd only have to design that house once, so you'd only have one blueprint for that house, but you'd actually build maybe 10 of those houses and sell them all individually, and each of those houses would have some variation and their own specific properties. They'd all be based on the same blueprint. And it's the same with a television. A company like Samsung, for example, sells hundreds of thousands of the same television. Now, once you get that home, you customize that television, but they're all from the same design. So the design for an object is called a class, and the actual instance of that object is an object. Think of it a little bit like this. So an object typically will contain all of the data associated with itself, as well as functions that operate on that data. So if we take a car as an example, and we're going to run with car as an example for a few more concepts, the data of a car would be its make, its model, and its color, and the functions or operations or that you can perform on that car, maybe start, stop, and move. So when you're designing a class, there are a couple of guidelines that it's quite important to follow. So a class should represent a very clear concept, such as a car or a television or a home. And it should provide a well-defined interface for things that you can do with it. So if we look at our car example, we've got 3 things that we can do with it. We can start it, we can stop it, and we can move it. And that's it. So a class should define a very well-defined interface of things you can do with that thing. And ideally, and one of the main strengths of object-oriented programming is you abstract away some of the complexities of the object. So for example, when we want to start the car, we don't actually care how that happens. You may or may not know, but when you turn the key in a car, the starter motor has to draw electricity from the battery, the starter motor needs to turn the engine over, and then it needs to ignite the internal combustion engine. Now, all of those things happen just at the turn of a key. All you care about is that you have the right key for the right car, and when you turn it, the car starts. And it's kind of the same thing with object-oriented programming. If you have a car object, you just want to call the start method. You don't care that under the hood, that car object is going and doing a whole bunch of other things. All you care is that you get the result that you expect. So that's what we're doing here. We want to abstract away the complexities of that object into something simple. Now, a lot of things, and especially as your program grows more complicated, will have external requirements. For example, a television requires electricity, or a car requires petrol or diesel. So it's very important that we document those external requirements and make sure that we can't attempt to start the car before we've put petrol in the petrol tank. Now, for example, if we're building a database type application or an application that reads from a database, one of those requirements might be the username and password for the database, or it might be the connection to the database, and the object can't function without that requirement. So it's really, really important that we document that requirement up front. And finally, the fields on the class represent the data, and the methods are the way we can interact with that data. So again, going back, the fields are these things here, the make, model, color, and the methods are start, stop, and move. And they will typically interact in some way with this data. Now, in order to start a car, we probably don't actually care about make, model, and color, but maybe we have some details about the engine or the fuel type, which are important for that start method. So here's an example of a class, a realization of the class of what we were describing on this slide here. So when we design a class in Java, it's going to look like this. So we say public class car, and then usually at the top we define our fields. Now, public is actually an access modifier. This means that it can be read from anywhere. I don't want you to worry too much about that for the moment. But we're saying we've got a string. The string is text. There's a make, a model, and a color. And then we have three methods. And obviously, of course, here there's no real implementation. We've got start, stop, and move. And each of those is just going to print out starting the car, stopping the car, or moving the car. So that's a realization of the design I showed you on the previous slide. We've got three fields, the data items, and three methods or functions. So when we're creating objects, think of a class as the description for a concept and an object as the realization of that concept. So the class of a car would be its design, whereas the object would be the car itself. And of course, we can have many instances or cars of the class, which is the design. So think about Ford and the number of cars that they sell. They only have to design one Ford Fiesta, but they can sell hundreds of thousands or millions of them. So the design is the class, and the car itself is the object. Now, importantly, each object should have its own identity. So for example, with a car, that's the registration plate or the registration number. Same in object-oriented programming. Each object should have its own identity, and objects of the same class are completely independent of one another. So if I buy a car and you buy a car, they might actually be of the same design, but my car might be red and yours might be blue, for example. And if I decide to change the color of my car from red to black, it doesn't change the color of your car from blue to black. Because those cars are independent, they just happen to share the same design. And of course, objects can be concrete things like cars, but also conceptual things like a database structure or a database connection. So an instance of a class is actually the object, and this is how we would create it. So if we define that car using the class here, and we want to instantiate it, we do it like this. We say car, my new car equals new car. And this obviously is the variable name. It can be anything you like. This is just saying that my new car is of type car. And this is calling something called the constructor method, which is a hidden method on the object, or at least it's hidden on our object, that just gives us a new instance of the car class. And then we're going to do three things. We're going to do system.out.println. We're going to get the make, we're going to get the model, and we're going to get the color. So these dots are used to access fields on the object. And then we're calling these methods on the object. So on my instance of this car, we're going to start it, we're going to move it, and then we're going to stop it. So we create an instance of the class, and then we do something with it.